Okay, so let's say we'll draw a mechanism and then we will label what types of motion different parts of it have. So let's say there's a slider here. And then we'll have a wheel here. And a crank. So each one of these little dots is a pin joint, means that it allows rotation. So the crank is connected to the wheel by a link, and then the wheel is connected to the slider by another link. So we want to label different types of rotation for each of these. So let's call this A, link B, the wheel is C, this link is D, the slider is E. So this is fixed. The slider can move in and out of the slot. This part right here is fixed to the ground. Also this center here, say that's behind it, this wheel is fixed to the ground, so it rotates around this center. So we need to label what types of motion do each of these pieces have. So we will say translation rectilinear, we'll say that's TR, curvilinear translation, TC, fixed axis rotation, we'll denote as R, and general planar motion will be G. Okay, so now think about it, label, figure out what types of motion each of these systems has. Now A, we know rotates around this fixed point. So this link has fixed axis rotation. C also rotates around a fixed point. It's a wheel and the center is fixed, so we can say that that is fixed axis rotation. Now the length of A and the radius of C are the same. So when B moves, it will be moving in this sort of curved shape as A rotates to the left, C also rotates to the left, and B will be moving to the left, but it will also come down a little bit. So B will kind of go in a pattern like that, but the ends move at the same speed. So this is curvilinear translation because B is always going to stay horizontal even though it's moving in the plane. Now E moves straight along the slot, just moves in this direction, forwards and backwards. That is rectilinear translation, straight line motion. And D is a special one. So since the left side of D is translating, but the right side of D is rotating, the combination of translation plus rotation makes general planar motion. So now we will look at a simulation of this. So you can see here, and the plots beneath show what's happening to each of the special points. So we see the wheel and the crank have fixed axis rotation. Then we can see that this curvilinear translation of the red bar, because it's staying horizontal, but it's still kind of moving in a circle. Then the slider's got the rectilinear motion. We can see that in the green. And then general planar motion from this blue link, because the left side is sliding, but the right side is rotating.
So whenever we're analyzing for translation, rectilinear, curvilinear motion, we don't look at the members or of anything, we just look at the endpoints.
Well, you do look at the members, so you just kind of have to see what's happening to this one. Like you can see it's moving side to side, it's moving up and down, and its orientation is changing.
Okay, I understand.
Yeah, so that's just this particular example illustrates translation on one end and rotation on the other end, but it doesn't have to be like that. Like if it's just moving in a crazy pattern, then it's general planar motion.